Welcome back to Basic Biostatistics 2 and with module number 2. In this module, I'm going to show you how to make descriptive analysis, frequencies, and how to explore variables in order to run as well tests for normality. Once you have a data file open, in my case I have the variable view open, I go to Analyze, I click on Analyze. We have the second on the list, it's called Descriptive Statistics. As you see, the first three are related to the task of today and of this module is frequencies, descriptives, and explore. These three functions is what you're going to need in this module for doing the exercises and the quiz. If you go to frequencies, you have a new window open called frequencies. On the left side we see our variables. So we see here, we can scroll down, we have the variable ages, you have the continuous variables, you have the categorical variables here in these three little dots, colors, and we have all the variables we have. By now you also should have the new variables you have computed in the previous module in data preparation, such as BMI category, age category, and physical activity category. Let us choose BMI category. We click on BMI category, we click on this arrow, and we move it to the variable window. In the variable window, which is this window here on the right side, is where we select all the variables from the left which we'd like to analyze. In this case, we'd like to make frequencies. We can go here on statistics and see what we will get. Here we can select, for instance, if you'd like to have quartiles for the variable chosen, if the percentiles, if you'd like to have a standard deviation, variance, range, if you'd like to have the minimum or maximum of the variable, or some information of central tendency. In that case, if I click cancel, we can have here in charts, we have options to ask the program to make charts. Let's ask, for instance, for a pie chart, which gives us a pie diagram, a graph, which basically later on we're going to talk more in module number 6. The chart values can be set as percentages. We click on continuous, and in format basically we can ask the values to be ordered by ascending counts, descending counts. Basically this is not really needed for our purposes, so we click on cancel. By clicking OK, the computer program or the SPSS will give us what we ask for, which is frequency for the variable BMI category. Wait a little bit. As you see, the program opens an output window, and here we're gonna have two tables and one graph. The first table, called statistics, tells us that we have 60 valid observations and no missing one. So each of the dwarfs have data on BMI category. If you're gonna have missing data here, then did something wrong in data preparation. The second table gives us the main result of frequencies. You can see here the data for the normal weight, the overweight, and the obese dwarfs. We have in the normal weight, we have a frequency of 17, which means we have 17 dwarfs who are normal weight. This is 28.3%. And as we don't have missing values, the valid percentage is the same as the percentage. Cumulative percentage, 28.3. We have 29 observations with overweight, which is 48.3%. Adding this to the 28.3%, we end up with 70.6.7%. So 70.6.7% of the dwarfs are normal weight or overweight. And as we ask for pie chart, we're going to have a pie chart for the body mass in this category. We have in blue the normal weight, the obese one in this sort of gray color, and in green we have the overweight dwarfs. This is what you get from frequency. Let's have a look what we can get from descriptive. We go back to descriptive statistics, we select descriptives, and as the previous one, we have a similar window open with the variables to choose from the left side and the variables which we like to have the analysis done will be on the right side of this window. So let's select, for instance, education. We click on education, we click on the arrow, and we move education into the variable window. Click on options, we can select a large variety of information about the variable, for instance the mean. We can ask for the variance additionally if you're interested in. You can ask for information regarding distribution, for instance skewness. And if you're happy with what we select, we click on continue, on OK, and the output file will calculate the descriptives. I will scroll a little bit down and we see here the information of descriptive statistics for the variable education. We see education has 60 observations, so none are missing. All blocks have information education. The variable education is a minimum of 5 years, a maximum of 12 years, so all the blocks have between 5 and 12 years of education. The mean of education is 8.55 years, with a standard deviation of 1.6588 years. We calculate the variance, and we get information of skewness, which is in regard to normal distribution or different kind of distribution the variable can follow. This is what we get from descriptive statistics. So you see frequencies and descriptives help us to understand a bit more of each variable. They give us a summary of the minimal maximal value that shows more or less how the distribution of the variable is and tells us a lot about the characteristics of each variable. That's why before analyzing data, it's recommended to use frequencies and descriptives to get to know more about your data. For instance, if in descriptive statistics education you find a minimal value of -3, you know that there has to be a mistake in the dataset because education cannot be less than 0. In that case, you can go back to the data file or the questionnaire and verify if what's the real value of this bar in education. So descriptive statistics and frequencies also help you in cleaning the data. You can find out some values. If there are values for systolic blood pressure of 1000, we know that blood pressure cannot be 1000, and we know that probably has or was an error in data entry. We can go back to the questionnaire and we can check what is actually the real value. The third function I'd like to show and analyze is explore. The explore function is done for continuous variables. As the name says explore, we can explore a bit more of each variable. Important is that under explore we can find the test for normality. As you know that a continuous variable can follow a normal distribution or not a normal distribution. In case that the continuous variable follow a normal distribution, we can use most of the tests like t-tests and ANOVAs. In case that the continuous variable does not follow a normal distribution, we have to use non-parametric tests. Therefore, before starting with statistical tests, you need to know whether a continuous variable follows a normal distribution or if it's not normally distributed. Otherwise, you end up with choosing the wrong tests. How to test for normal distribution? Let's have a look at systolic blood pressure of month number 1. We'd like to know if this variable follows a normal distribution. So we click on systolic blood pressure, we select the dependent list. In display, we always choose both, which means statistics and plots. We go first to statistics, and we can here select some additional information if we're interested, for instance outliers or percentiles. Click on continues. Important, we go on plots, and in plots we're going to find normality plots with tests. We have to tick this box because this means that this is test for normality. If we do not select this box, we will not have the information on the normality of the variables. As I don't like that much stem and leaf diagrams, I select histograms and deselect stem and leaf. Box plots I'm not interested in, so I click on none. If you like, you can leave it and you can find out what the output file would give you. We click on continue. If you're interested, you can see what you find in the options. In the options you can find information on missing values. This data file doesn't have any missing values, so It doesn't matter what we select. By clicking OK, SPSS calculates you a lot of information about the variable systolic blood pressure. First, we're going to have a case processing summary table in the output file, which tells you that we have 60 valid observation, which is 100%. We have no missing cases, which is 0%. The second table gives you descriptives of the variable systolic blood pressure. As you see, actually Explore gives you much more information than just descriptives, as we used in the previous example. So we're going to have the mean value of systolic blood pressure month 1, which is 133 with a standard error. We have the 95% confidence interval, the lower bound and the upper bound. We have the median. We have the variance, the standard deviation, the minimum and maximum values. We see that systolic blood pressure minimal is 116, the highest 150, and information regarding distribution. Then we come to the interesting table which we're interested in, which tests for normality. SPSS always calculates you the Kolmogorov-Smirnov tests and the Shapiro-Wilkinson test. For large sample sizes more than 40, we should use the Kolmogorov-Smirnov test. If our sample size is less than 40, we use the Shapiro-Wilkinson test as it's more precise for small sample sizes. As you're aware of, in this sample size, or in this sample of the Santa Claus Super Study, we have 60 observation, which is far more than 40. So we check the information on the Kolmogorov-Smirnov test, which is here circled with the mouse. If you run a statistical test, we start with a null hypothesis. In Kolmogorov-Smirnov test, the null hypothesis is that there's no difference between a normal distribution and the distribution we have observed, or in other words, that the variable is normally distributed. This is the null hypothesis. Now the test calculates you a statistical value for the test, which ends up at 0.15, which is the statistical value of the Kolmogorov-Smirnov test, the degree of freedom of 60, because you have 60 observation, and the p-value. In SPSS, the p-value is written as significancy. We see the p-value 0.002. We also know that in hypothesis testing, we usually set a threshold of 0.05. So if the p-value or the significancy is more than 0.05, we accept the null hypothesis. If the p-value is less than 0.05, we reject the null hypothesis. In this case, the p-value of significancy is 0.02. This is less than 0.05. Therefore, we reject the null hypothesis. The null hypothesis was that the variables normally distribute, so we reject it, which means the variable systolic blood pressure month number 1 is not normally distributed. From now on, if we have to analyze something using systolic blood pressure of month 1, we have to use non-parametric tests. If you go further down, the program gives you a nice histogram, and we see actually this histogram, the distribution of the systolic blood pressure value doesn't really look like it would follow a normal distribution. So by now you know how to test variable for normality, and you only have to test continuous variable for normality, because categorical variables never follow a normal distribution. You will see in the exercises you're going to be asked to test each continuous variable for normality. In the end, I'd like to show you something else in Explore. You go back to Analyze, you go to Explore. We can actually explore a variable separate for different categories. For instance, we like to know the systolic blood pressure separately for non-smoking dwarfs or smoking dwarfs. This, for instance, could be important if you analyze data separately for the non-smoking dwarfs and the smoking dwarfs. In order to separate or to have the values separate for a certain category or categorical variable, we select, in this case, smoking status, and we add it to the factor list. By adding to the factor list, we're going to have all the results separately for smoking and non-smoking valves. We click on OK, as the previous settings are still valid. We wait for the results, and we see now in the case processing summary that we have 30 non-smoking valves, 30 smoking valves. The second table, which basically gives us the information, we can see that we have first information for the non-smoking valves, and afterwards the information for the smoking valves. So all the information regarding systolic blood pressure month in the first part of this table is for the non-smoking valves. We see that the non-smoking valves have a mean value of blood pressure of 131.83, whereas the smoking valves have a mean value of 135.83. This maybe helps us to generate some hypothesis. We can think of, it seems to be that the smoking valves have a higher systolic blood pressure. So we could maybe write down a research question that you would like to investigate whether the smoking valves have a higher systolic blood pressure. In that case, will be needed to use a certain statistical test, which we'll talk in Module 4, how to see if this difference is statistically significant. To summarize, under Explore, we can get more information regarding a variable. We can separate the variable for different categories and check if there seems to be a tendency of differences. And importantly, we find the normality tests in Explore. In normality test, important to keep in mind that the null hypothesis is that the variable is normally distributed. You run the test. Based on your sample size, you select Kolmogorov-Smirnov or Shapiro-Wilkinson test. You check whether the p-value or significance is higher or lower than 0.05, and based on this, you're going to make a decision whether the variable follows a normal distribution or if it doesn't. Thank you very much for listening to the information of module number 2. I wish you good luck with the quiz and the exercises. You can watch this video as many times as you want. Try to test it, explore these functions in SPSS, and once you feel familiar with how to run the analysis of descriptive frequencies in Explore, I invite you to do the quiz and the exercises. Thank you very much, and have a great day.